Hello, today we're starting Unit J, which is trigonometry. We're going to start the unit by reviewing right triangles. So let's get started with the Pythagorean Theorem. The Pythagorean Theorem is what we use to solve for a missing side of a right triangle. The Pythagorean Theorem is the square of the measure of the hypotenuse equal to the sum of the squares of the measure of its legs. Most of you guys know it as a squared plus b squared equals c squared. I like to define it as the leg squared plus the other leg squared equals the hypotenuse squared. Now, just to refresh your memory, the two sides that form the right angle are called the legs, and the side opposite the right angle, otherwise known as the longest side, is the hypotenuse. Okay, let's go ahead and get started and try the first example. Now, the first example, we are missing a leg, so we're going to do 9 squared plus x squared equals 15 squared, and this is just very simple algebra. So go ahead and square the numbers that you can, so 81 plus x squared equals 225. Subtract 81 from both sides, and then go ahead and get x all by itself. How do we get x all by itself? We square root both sides. Now normally when we were doing this, we were putting a plus or minus in. We don't need the plus or minus because it doesn't make sense to have a negative side of a triangle. So the answer to this is just 12. Okay, go ahead and pause the video here. Try the U-try. Now this one, you're missing the hypotenuse. So you're going to set it up by doing the leg squared plus the other leg squared equals x squared. Okay, moving on to what we call Pythagorean triple. Now some of you especially may remember the 3, 4, 5 triangle. These are numbers that always satisfy a squared plus b squared equals c squared, and they're always whole numbers. So you did learn these in geometry, but to refresh your memory, we have a 3, 4, 5 triangle, an 8, 15, 17 triangle, a 5, 12, 13 triangle, and a 7, 24, 25 triangle. Now what does that mean? It means that if I do 3 squared plus 4 squared, that will equal 5 squared. So for example, let's say this was an x instead. I can take a look at this example and say, oh, the legs are 3 and 4, my hypotenuse must be 5. And you save yourself some time using the Pythagorean theorem to solve. These are the most popular ones. There's infinitely many. You will see these definitely on the ACT. It just saves you time. So we're going to go ahead and refresh our memories and practice it a little bit. Now, when you get good at this, you don't need to write it out. I'm just kind of showing you what my brain is doing. So if I look here, I say, oh, I'm missing a leg. Do we have an 8 something 17 triangle? Yes, we do. We have an 8, 15, 17 triangle. So I know in this case my x is 15. Now sometimes it doesn't always work out like that. I take a look at this one. I don't have a 33, 44 something triangle, but I can see that I can divide 11 out of both of these. There's a greatest common factor here. When I do that, this would be my 3 side, this would be my 4 side, so that means I know I have a 3, 4, 5 triangle. Now x is not 5, x is what? 55. Because what did I do to get my actual sides? I multiplied the 3 and the 4 by 11. So I also have to multiply the 5 by 11. Okay, go ahead and pause the video and try this U-try. Now, again, you can recognize that there's a greatest common factor. So do that first. Take out a 2 to see which triple it is. Okay, now, we have such a thing called 45, 45, 90s and 30, 90 triangles. What happens in a 45, 45, 90 triangle or a 30, 60, 90 triangle is the sides have a certain ratio of each other. So if I take a look, in a 45, 45, 90 triangle, we know that both legs are going to be congruent because it's an isosceles right triangle. And we know the hypotenuse is going to be root 2 times that. Okay? So here's the hint. If you are given a leg and you need to find the hypotenuse, you're going to take that leg and multiply it by root 2. If you're given the hypotenuse and you need to find the leg, you're going to take that hypotenuse and divide by root 2. So let's go ahead and try this. You definitely should memorize this. So what I tell students to memorize it is x root 2. Okay, so this is how I do these problems. This is a little bit easier than the 30, 60, 90. I see that I have a leg, okay? So I know if this leg is 9, this leg must be 9. I am missing the hypotenuse. So I'm going to take my leg and multiply it by root 2. Now when we multiply, remember, we don't mix insides and outsides, so our answer is just 9 root 2. Okay, now this problem, I have the opposite. I'm given the hypotenuse, I don't know the legs. So I'm going to take our hypotenuse and I'm going to divide it by root 2. Now, you know we can't leave an answer looking like this because there's a square root in the denominator. So we're going to go ahead and multiply by root 2 over root 2. Now, when I do that, remember, don't mix insides and outsides. We get 6 root 2 over 2. Now, these are both outside, so we can go ahead and simplify that. Our answer is 3 root 2. So both of our legs, even though I only asked you for one, is 3 root 2. Okay, go ahead and pause the video and try this. You try. It looks messy, but it's not. You can do that, okay? Give it a try, and we'll see what you have tomorrow in class. Okay, now, 30, 60, 90 triangle is a little bit more difficult. I'll show you the way I like to do it. I like to make algebraic equations. So you do need to memorize that opposite of the 30-degree angle is our x. Opposite of the 60 is where we take our shorter leg and we multiply it by root 3. Opposite the hypotenuse is where we take our shorter leg and we multiply it by 2. I'm just going to get started and then you'll pick up on this, but keep in mind I do want you to know that. Okay, so here's the first thing I do. I know if I see a 90 degrees and a 60 degrees, this must be my 30-degree angle. So opposite the 30-degree angle is going to be my x side. Now sometimes it's a little bit confusing when they want you to find the missing side and it's also an x, so I like to change it to a question mark. That's the side I want to find. This side is opposite my 60, so I'm going to go ahead and put in x root 3. And this side is opposite my 90, so I'm going to put 2x. Now whatever side you're given is the equation you're going to make. I was given the hypotenuse. This is my equation. 2x equals 8. Go ahead and solve. Very simple. We know that x is 4. Now, if I wanted both missing legs, just make sure you plug x back in. This leg would be 4, and this leg would be 4 root 3. So our x that was missing, or if you want to call it a question mark, I like that better, it would just be 4 root 3. Okay? All right, let's try another one. So again, the side that I'm missing in this problem happens to be the hypotenuse. So I'm going to call that question mark instead. I'm going to go ahead and put my ratios. Opposite the smaller angle is x. Opposite the 60-degree angle is x root 3. And opposite the 90 is 2x. Now, this is the side I was given, so that's my equation. My equation is x root 3 equals 9. I need to get x all by itself, so I'm going to go ahead and divide both sides by root 3. Now, you can't leave your answer like this, so I'm going to go ahead and multiply the numerator and the denominator by root 3. When I do that, I get 9 root 3 over 3. This simplifies to 3, and I get root 3. This is x. All this work I did is for x. Okay, this is now x. I don't want x. I want the hypotenuse. So I'm going to have to take this and substitute it in. So you have 2 times 3 root 3. Multiply the outsides together, and my missing side, my hypotenuse, is 6 root 3. Okay? Go ahead, pause the video, and give this you try. I want to see tomorrow, even if you don't have the correct answer, I want to see your ratios labeled. I want to see your equation. This is actually a very simple one. I saved the most simple one for you guys to try on your own. Once you solve for x, plug it back into your missing sides. Now, we use trigonometry when we don't have a ratio of a triangle. So when I say a ratio, okay, up here, we knew that the legs of a 45, 45, 90 triangle, to get the hypotenuse, we just take a leg and multiply it by root 2. Okay, same thing with 30, 60, 90. We take the shorter leg, we multiply it by root 3 to get the longer leg, and we multiply it by 2 to get the hypotenuse. Now, what if I have a triangle that's like 41 degrees, 39 degrees, 90 degrees? We don't have ratios for every single type of triangle. So when we have those triangles, we have to use trigonometry. Now, you learned this again in geometry. The best way to remember trigonometry is by remembering SOHCAHTOA. Hopefully you remember what that is, but I'm going to go ahead and give that in review with you. Okay, so you remember this by the sine of an angle is the opposite over the hypotenuse. The cosine of an angle is adjacent over hypotenuse. That's where the AH comes in, ca. Tangent is the opposite over adjacent. And you'll remember this as I go ahead and start doing the examples. Now, the first set of examples, we're only writing the ratios. When it says ratios, there's no punching into your calculator. Notice I asked you for the sine, cosine, and tangent of angle B. That means our starting point is angle B. So in relationship to angle B, this is called the opposite side. This is called the adjacent. Adjacent means next to. Now technically we have two sides that are next to that angle, but this side is special because it's the hypotenuse. Okay, so if I want the sine of angle B, that means I start at B and sine was so. I want the opposite over the hypotenuse. So 1 over root 5. Now I would leave my answer like this, except that I can't leave a square root in the denominator. So I'm going to go ahead and multiply the top and bottom by root 5 over root 5, and I get root 5 over 5. Done. No punching in calculator because it says ratios. Ratio is a fraction. Okay, now I'm going to do the cosine. Cosine is ca, so that's adjacent over hypotenuse. So I get 2 over root 5. Again, we can't leave a root 5 in the denominator, so we multiply by root 5 over root 5, and I get 2 root 5 on top and just 5 on bottom. Nothing can be simplified. Last one is tangent. Tangent is toa, so ka-toa. So we're going to do the opposite over the adjacent. There's nothing I need to do to simplify there. My answer is just 1/2. Okay, now we're going to do the same thing, except we're going to solve for something that's missing, a missing side or a missing angle. And I'm going to show you how to do that on your calculator. Okay. Oh, yeah. Let's start right here. Sorry, I thought I had a U try for that one, but I don't. Okay, we're going to find the value of x to the nearest tenth in relationship to the angle that I was given. And by the way, you are never, ever, ever going to start with a 90-degree angle. In relationship to the angle I was given, this is my opposite side, and this is my adjacent. So which trig function, so ka, toa, has to do with opposite and adjacent? And that would be tangent. So I'm going to do the tangent of my angle, which is 54 degrees, and I'm going to set it equal to the opposite first over the adjacent. Okay, our next step is to actually calculate what the tangent of 54 degrees is. So go ahead and go to your calculator. Everybody right now click on mode. You see how my mode has highlighted radians? You will get all the wrong answers if that's the case. So go down to the third row, scroll over, and highlight degree. Okay, now I will get the right answers. So we're going to go ahead and do tangent of 54. You don't need to close your parentheses in this case, and hit enter. Now please keep 3 to 4 decimal places. So I'm going to replace tangent of 54 with 1.3764. I'm rounding that 3 to a 4 because it's 8 is next to it. Now just solve for x. How do I solve for x in this problem? I multiply both sides by 10. That's it. X is now by itself, so I go ahead and multiply this answer by 10. And I get x to be, we're going to round sides to the nearest tenth, and we're going to round angles to the nearest degree. So this is 13.8. Done. Most of the time these will not work out perfect, because if they did, we'd probably be able to use a 30-60-90 ratio or a 45-45-90 ratio. Okay, let's go ahead and you pause the video and you try number 1. Remember, set it up and say in relationship to this angle, in relationship to the angle that was given, you have the opposite side and the hypotenuse, okay? So that will help you tell what trig function you need, but I definitely want you to give it a try. Okay, now we're doing the opposite. We're finding the missing degree. So we're going to start with the angle that we want, okay, which in this case is this one. In relationship to this angle, this is the adjacent side, and this is the hypotenuse side. So I know I'm going to use cosine. So I'm going to set this up. I'm going to do cosine of x equals the adjacent first over the hypotenuse. Okay, now we're going to work our calculator a little bit differently here. So we're going to go ahead and we're going to go, let me just erase this so I can put it on the calculator and you can see it. Let me clear this. Okay, we're going to go ahead and do 10 divided by 27 first. Again, if possible, keep 3 to 4 decimal places. Okay, we get cosine, the cosine of x equals 0.3704. Now, what you're going to do on your calculator is you're going to make sure you hit second cosine. You need this little -1 to pop up because we're finding the missing angle. And then you're going to go ahead and put in your decimal, 0.3704, hit enter. Round this to the nearest degree, so it's 68.2, so 68 degrees. We're always going to round sides to the nearest tenth and angles to nearest degree. Go ahead and pause the video and give the next one a try on your own. Do the same thing in relationship to that x, which 2 sides do I have, and then don't forget to hit second, whichever trig function it is. Okay, if you have any questions, comments, or concerns, go ahead and write it on the bottom of the paper, and I'll see you tomorrow in class.